In this example, we'll use cross-section plan viewer to draw cross-section profiles overlapped with a satellite image and identify what the surveyed cross-section actually represents in terms of river morphology. Here are the cross-section cut lines representing survey data. In order to link the cross-section cut lines to the text file with the station and elevation data, the streamline has to be digitized so as to give the cross-section order, which has to match the one in the text file. It is mandatory that the streamline intersects all the cross-section cut lines. Here we follow the main channel path, but actually we might follow any path intersecting all the cross-sections, as we are doing here. Skipping to the end of this process, intersect the last cross-section cut line and finish the digitization. We can see the streamline which covers the entire river reach intersecting all the cross-section cut lines. Save the streamline in the KML format, not the KMZ format. Load the files required to run cross-section plan viewer. The cross-section cut lines file, which identifies the location of the surveyed cross-sections. Then the text file, including the station and elevation coordinates of the surveyed cross-sections, and the streamline just digitized in Google Earth. Since Google Earth uses the geographic coordinate system, let's specify here the UTM zone, which in this case is the zone 32 north. Then here are the three output files. The first one represents the cross-section profile. The second one is for the linking segments connecting the cross-section profiles points to their corresponding location along the cross-section cut line. And finally, the text file with the name of the cross-sections. Choose then the type of output in KML format and the vertical axis scale factor. Upload the two files generated by the program cross-section plan viewer, which will allow for the visualization of the cross-section profile over the available map and for a better understanding of what they do represent. Let's have a look. The cross-section here is not perpendicular to the flow, which is not very useful for a one-dimensional model. Then here is another particular case where the cross-section does not represent only the main channel but also a tributary. Here is a groin, which should be accounted for in the model implementation for low flow conditions, and in the right of a bank there is a pit. Going on with the analysis, here is another groin, which covers also the deepest portion of the cross-section, preventing the discharge for low flow conditions. Then, towards the river mouth, this section here shows two channels. One of them is not active for low flow conditions, and this has to be taken into account. That's the link to the website from where it is possible to download the demo version to test the software.